Hello, we're back in the basement lab, the underground lab. It's quite chilly today because the heating's not on. What I want to do first is to show you this, the antenna in a little bit more detail, because the last time it was a bit dark and you couldn't quite see it and it's all out of focus. So I've taken off the little Lego carrier thing that we used on the turntable. I might redesign the turntable just so it's a little easier to put things on and take them off again. I'm also going to change the cable here for this cable with a BNC socket on, so that will go into here, into the antenna, just to make things a little bit easier to swap around for later, where we're going to do some antenna comparisons. But concentrating on this antenna now, you remember that I cleaned off the previous coating using some methanol, and the antenna was completely clean. The little bit at the end was taken off by the alcohol, and we ran some tests with the antenna with no coating on, compared it to the previous test with the antenna with a coating on, and then we compared it to the antenna with this nasty manky brown varnish on. The varnish should be clear varnish, but unfortunately I've only got quite an old tin of varnish here, which, I mean, look at the hair on that guy there. That's got to be 1980s varnish, and it should be clear. It is not clear. It is become unclear. So the antenna now, it's been dipped. It's dry. Let's have a little look at it and see if we can recognise any features of this antenna here. And of course we can, because what you see immediately is it's got its shine back. If you wave it in the light, you see the coating has made the antenna shiny as it was before, but more particularly at the end, it's got this little bobble again here, and that is what somebody's claimed is a dielectric lens. I mean, the claim is laughable, because 868 megahertz. That will have absolutely no effect whatsoever. You've probably seen Andrew McNeil's video. Andrew McNeil is an excellent YouTuber. He has a really interesting set of videos on his channel. Have a look at Andrew McNeil, and he looks at this antenna in close detail, and he actually made a mock-up dielectric lens for this frequency, and it was pretty big. So this is not a dielectric lens. It just isn't. But of course what happened here is, I dunked this into the varnish. It went in like so. I pulled it out and I left it to dry, and the varnish dribbled down the side here and left a little drop at the bottom there, and gradually it dried and became a drop at the bottom of the antenna. And that is all it is. You see, we've recreated the drop ourselves here in the lab, and that's all it is. It is not printed on, it is not manufactured on, it is the remnants of dip in a conformal coating to protect the circuit board from corrosion and damp. And we know that as well because they dip the whole thing in it, and you can tell that because look, the whole thing is shiny there. That is the coating shining, and you can see some of the components. If I zoom in a bit more, some of the components even, can you see that? You can see it's all shiny and lovely. The components, they've got that shiny sheen on top there, which is that coating. So the whole thing has been dipped in the conformal coating. I didn't clean this bit off because there's no need to, and that is why the whole thing is covered in it, and that's why you have a little drip at the end down there, which is just a drop of the coating. But in this case, it is a drop of varnish, which I put on there in the last video. So what we're going to do next, and the reason why I'm going to change this antenna cable in just a moment, is that I want to compare some antennas. I want to compare this antenna here, and why do we want to compare the antennas? Well, we want to compare the antennas because we want to see what the relative gain of this antenna is versus some other antennas. And some antennas that I make would be a bit of a joke, because why not? It's funny. So the first antenna I will compare it to is this here. This is a rusty nail antenna. It's actually rusty screws. So I've got two rusty screws which I'll pull out the wall outside, and they have been cleaned just at the end here and soldered onto this plug, and this has made a dipole. I've had to put a bit of wire up here because this screw is a bit shorter, so that wire, make sure it is 1/4 wavelength long. So we'll compare the Harvard antenna to this antenna here, and we'll also compare it to another antenna I made. This is a spoon antenna. This is 2 teaspoons stuck onto a plug of the right length. So again, it's a 1/4 wave at each end, so making a 1/2 wave dipole. We'll compare that antenna as well. The next antenna we'll compare is a slightly more professional looking dipole. If I can find it. That's professional, isn't it? I've lost it. One moment please, I will find the other dipole antenna to which I will compare it. How can I lose an antenna? Just stunning, isn't it? Oh, no, here it is. It was hiding. Okay, so I'll compare it to this antenna here. So this is a slightly better dipole made of some thin piping and the cable here. And it again has a BNC connector on to make it easy to change around. And then the last antenna that I will try in this trial is a CAN antenna, but not the CAN antenna that you see me earlier with. This is a soup CAN antenna. So basically it is 2 tins of Heinz cream of tomato and basil soup, and inside there I soldered the wires for this connector on, and so we will try the soup CAN antenna as well. So that's the Harvard antenna, the rusty screw antenna, the spoon antenna, and the soup CAN antenna. And we'll just have a look and see which one of these antennas provides the highest gain. So here we are. This is a quick test of the Harvard antenna. So here we are. I put the antenna on a bit of a more sensible test platform with some foil on to make sure there's no capacitive effects or other effects that could affect the test results. The other antenna is across the other side of the basement here. There we are. And that is connected to another software-defined radio. And we're sending a signal across the room here between these 2 antennas. And what we should see, if Mark is right, is that the signal on this side will be higher than the signal on the reverse side, because the claim is that it's a high gain directional antenna. We've already seen it is not directional and it's not high gain, but just to do it again, we'll do it again. The claim is, of course, that this side is directional where the main lobe is. So let's test that. So what I'll do is I'll just bring the camera around here to where I have the spectrum analyzer receiving the signal. There you are. I'll make sure I don't touch anything whilst I am moving the camera around. Yeah, that antenna is still visible there. So that antenna is still pointed towards the other side, the other antenna. There we see that side has not got that strip on, so the strip is pointing towards the other antenna. Let's look at their received signal strength. There we are. Okay, so the current received signal strength is neg 29.5 dB. So minus 29.4, 29.5 dB. What I'll do now is I'll turn it around so it faces the other way. And we should see, if it's high directional and high gain, a significant difference. There we are. It's turned around, and the signal is neg 28.3. So it's actually a very slightly better signal, but nothing to write home about. It's sort of maybe half a dB, 1 dB in it. So there we are. So neg 28.3, 28.4 maybe, yeah, there we are, 28.3, 28.4. And the antenna is currently facing toward us. There's a strip. So what I'll do is I will just I'll turn it around again. So we get another reading. So the strip is now going to point towards the other antenna, and our signal strength is, let's have a look, 28.7. So it's pretty much identical. So whether or not you have the strip pointed towards or away from the other side, the signal strength is almost identical. It's almost like it isn't actually directional at all. Isn't that curious? Let's do it again, shall we? Just to make sure we're not doing anything strange. Let's have a look. So there we are. So it is now pointed towards, the strip is pointed towards the other side, the other antenna. I'll turn it around. There we are, turned around. Again, just so you can verify that. There's the strip again. Now it's on this side. And the signal strength is minus 29.1, 29.3 it was just now. Pretty much identical. So there we are. This antenna is not directional. There is no high gain in the direction of the strip. It's just complete and utter nonsense. Utter nonsense. And to prove it a little bit more, I have another exciting antenna here. Where have I put it? I've lost my antenna again. Stunning, isn't it? Oh, we'll use this one first. This antenna here is this is one I made earlier. There we are. This is the spoon antenna. So what I'll do, I'll detach the Harvard antenna, I'll put the spoon antenna on, and we'll see what happens with the spoon antenna and see what the signal strength is like then. Here, so the spoon antenna will need a little adapter, which I've left plugged into here. There we are. Right, so spoon antenna is ready to go. I'll just, where shall I put it? I'll take the same, roughly the same distance away. There we are, like that. Was that there, wasn't it? So spoon antenna. The spoon antenna, we get minus 31-ish. So not as good as the Harvard antenna, but you know, it's two spoons, and it's a couple of dB difference. Maybe I'll move it around a bit, I'll get a slightly better signal. Let's have a little fiddle with this, shall we? There we are. How's it looking now? No, it's about the same. So, sort of negative 30 we had earlier, didn't we, on the spoon antenna? There we are, negative 30 for the spoon antenna. Not too bad. Okay, so we're going to try the rusty nail antenna now. So I just set the rusty nail up next door to the Harvard antenna there, as you can see. There we are, rusty nails, and the cable goes down to the software-defined radio and into the spectrum analyzer. And the receive signal on the rusty nail is minus 28.6, 28.7, so neg 28.5, 28.6 for a rusty nail. And just to do a quick comparison to the Harvard antenna again. So Harvard antenna versus rusty nail. I need the adapter. And the Harvard antenna is neg 29.7, about what it was before. So actually we found that our rusty nail antenna is better than the Harvard antenna. So Mark, how do you explain this? How do you explain that a rusty nail antenna is higher gain, or roughly the same, maybe a tiny bit higher gain than your high gain superdirectional Harvard antenna? Why is that, Mark? How do you explain this? Because it's bizarre, isn't it? It's almost like you don't know what you're talking about.